Ever wonder how robots learn to master complex tasks, like cleaning a table or moving objects, without being explicitly programmed for every detail? Today, we're exploring a groundbreaking approach called SLAC, a method that's revolutionizing real-world robot learning by making it faster, safer, and more efficient. Let's dive into the science behind it. Here's the challenge. Training robots in the real world is like teaching a toddler to solve a Rubik's Cube. It's slow, error-prone, and risky. Traditional methods either rely on perfect simulators, which are notoriously hard to build, or throw robots into the real world without a safety net. But what if robots could practice in a virtual environment first? That's where SLAC steps in. SLAC stands for Simulation-Pretrained Latent Action Space. Think of it as robot training wheels. The core idea is deceptively simple. First, let the robot learn basic skills in a rough, low-fidelity simulation, a virtual playground where mistakes are cost-free. Then transfer that learning to the real world. But how does this actually work? The magic happens in two stages. First, pretraining and simulation. Imagine a robot exploring a virtual kitchen, experimenting with arm movements, avoiding obstacles, and grasping objects, all without explicit instructions. This is called unsupervised skill discovery. The robot isn't told what to do. It discovers patterns through trial and error, building what's called a latent action space, a compressed, abstract representation of movements. It's like teaching a toddler to wiggle their fingers before asking them to write. Second, real-world adaptation. Once the robot has this foundation, it moves to the real world. But here's the twist, it doesn't start from scratch. Using the skills from simulation, it tackles tasks like wiping a table or pushing an object into a tray. And it does so in under an hour of real-world practice. No need for human demonstrations or endless coding, just smart exploration and feedback. But how does SLAC keep robots safe during this process? It employs a safety reward system. Think of it as a virtual guardian. If the robot tries to slam into a wall or apply excessive force, the system gently nudges it away. This ensures the robot learns efficiently without causing damage, virtual or real. The results are staggering. In tests, SLAC succeeded in 90% of tasks, compared to just 20% for competing methods, while minimizing accidents. It's like giving a robot a head start by letting it dream in a virtual world before facing real challenges. So why does this matter? SLAC bridges the gap between simulation and reality. It's not just about speed. It's about creating robots that are adaptable, safe, and ready for the messy, unpredictable world we live in. Whether it's cleaning your home, assisting in a factory, or exploring space, this tech is bringing us closer to robots that learn like humans, through experience, not just programming. Imagine a robot not just following rigid instructions, but learning to clean a room like a human would, figuring out how to dodge obstacles, balance a broom, or sweep trash into a bin. Researchers tested SLAC on two challenges: a whiteboard cleaning mission where it had to wipe surfaces while avoiding chairs, and a table setup where it pushed garbage into a tray or swept it into a bag. These tasks sound simple, but they're deceptively complex, like asking a robot to multitask with the finesse of a seasoned housekeeper. What sets SLAC apart? Unlike older robots that require hours of human guidance or perfect environmental blueprints, SLAC learns autonomously. It doesn't wait for demonstrations. It experiments, tries things out, and improves over time. Think of it like a robot learning to fold laundry by trial and error. No tutorials, just curiosity and persistence. This isn't just about efficiency. It's about redefining what robots can do. Imagine a future where robots adapt to any mess, any room, any challenge without constant human input. Whether it's scrubbing a kitchen after a party or clearing debris in a disaster zone, SLAC's approach could make robots smarter, more flexible, and way more useful in our everyday lives. Next time you see a robot in action, remember, it might not just be following orders. It could be learning, evolving, and solving problems in real time, just like we do. Thanks for watching. If you want more deep dives into how AI and robots are shaping our future, hit subscribe. See you next time.